Today, we welcome to the USF Data Science Speaker Series, Chakravarthy Nagarajan, who is the Principal Solutions Architect at AWS and a seasoned expert in Gen AI, big data, high performance computing, and cloud infrastructure with over 2 decades of experience in the tech space. At AWS, he builds transformative solutions that help enterprises harness the power of cutting-edge AI technologies. Today's session will be about building intelligent agents with the AWS Generative AI ecosystem. Please join me in warmly welcoming our speaker.
Good afternoon, everyone. Am I audible? Okay, thanks for the intro. Thanks for the intro. I'm excited to be here. I go by Chakra, so feel free to interact. It will be more interactive and intra if you have questions. So let us, make use of this session very productive, right? So it's not only me talking. I would love to learn and hear from you as well. So today's topic, it's about building intelligent agents in AWS AI ecosystem. So how many of you are already using or building agents? Wonderful. So then I would love to hear from you. Okay, what kind of agents that you build? And it could be anything.
Building an agent that goes to a site and evaluates that site for how well it is, or how easily navigable it is by other agents, and providing an analysis for how to improve the site so that other agents that want to interact with can get better success rates, shorter execution times, and stuff like that.
Interesting. So bear with me, I'm going to go through some basic concepts in between. It may be a kind of a repeat for some of them who are already using or building agents, but for the benefit of everyone, let's go through some of the concepts as well. So without further ado, let's move forward. So here is our agenda for the day. So in a nutshell, this agenda split into 2 parts. One is how you build a foundation. The foundation could be your data and model. And next is building the agents. Because the agents are in standalone, right? It cannot work on its own. You need a strong foundation in the backend. Either it's a model or it's an ecosystem of multiple models together. And finally, we are going to look at the customer stories who already adopted AI agents in AWS ecosystem, and then we'll go through some of the stories. And finally, I'm going to give you some kind of a code references for you to try it out, right? I'm going to share different GitHub repositories, which we normally maintain with the latest and then greatest updates. Right. Start with an AI implementation journey. How customers are adopting generative AI. So it all starts with the use case discovery, right? So don't ask me how do I search or find out which use case. So do not start with the question of which use case to start, right? You need to have a clear understanding about which use case to start and what kind of a business, the success that it's going to bring in, right? So we call this a business case. And while you start prototyping a specific use case, please be clear about the success criteria. Because without the success criteria, it's a never-ending story. It keeps going, right? So pick a use case, start doing a prototype. Before that, define your success criteria. Data and model foundation. So today, the first half, we are going to focus more on the model foundation, because data foundation is another story that may not be able to fit within the session. But we'll focus on the model foundation. So what kind of a data sources are you going to pick? What are the different models, right? And how to choose the model, etc. And the next comes the security compliance and the legal approvals, etc. So from organization to organization, it varies Well, for example, the life science organization, some of them need HIPAA compliant services and the models that you would like to use. Or like in Europe, the GRP is like kind of another compliance of what people look at. So compliance is very important. Next comes the responsible AI. How do you handle the hallucinations? How do you monitor? How to handle the prompt, the jailbreak or the prompt injection, etc. Or content filtering. So what are the different best practices and then how do you apply them? And finally, you reach a proof of value, which means the POC or the prototype what you build, that's a successful, right? So you are able to meet that success criteria functionally or technically. So technically, you are able to meet the success criteria. Next comes the decision point. Okay, is this enough for me to put this solution or system into production? How do I scale from here? Right, I mean, he mentioned about the agent. Is that agent, can it be scalable in production? Or is that GenAI solution, what I built as part of this POC, is it scalable across hundreds and thousands of users, right? So that's where you further optimize it, develop an ecosystem to evaluate this model very frequently, and then incrementally retrain and then do a lot of optimization around the throughput, latency, performance, etc. And at last, the observability. Monitoring is one of the important aspects because without you understand what's going on and what kind of token generation or the error it throws continuously on a continuous manner, you won't be able to further improve this model performance or agent performance. So at last, you end with the business value. So you start with the use case and end with the business value. So from an AWS AI perspective, there are three major primitives. One is freedom to invert, right? In other words, flexibility. So we don't say that you have like one model and that's it. You are done with it and you can do anything and everything with the same model. Not like that. You need a set of models because one model may be good in like one specific use case, while the other model can provide you better flexibility to train it on your own data set or fine tune it on your own data set. And one model may be like large enough that it has a broad general knowledge, like for example your GPT models or the Claude models. They are like big enough, they have a broad knowledge, which is good enough for your use case. But there are few models, for use cases like it may not fit in. Like for example, you have a healthcare company. The healthcare company has its own set of data, which cannot work directly on those models. So you have to fine tune those models to work with your own data set. So there are multiple such criteria that you may need to look at before you decide what kind of a model, or it could be a combination of multiple models. So the choice of models is very, very important. So the ability to choose different models, different data sources. Your actual data can come from different sources. It could come from a simple S3 bucket, or it could come from your own database, or it could come from a vector DB, or it could be somewhere else, right? Somewhere else outside AWS also. So what are the different data sources that you have to handle? So the choice of data sources, the choice of different models, and more importantly, the choice of tools. That's very important to build an AI agent. So why do we need tools? Any idea?
We need to implement AI.
Sorry?
We need to implement the AI agent, the idea.
Right. But then why? Why do we need tools? Because the model is good enough that it knows everything. Why do you need a tool? Right. So the model may be trained with the knowledge of like last year or last 6 months, right? So it doesn't have that recent knowledge or the ongoing current events. If you want to build a system or a solution which is based on the current events which are getting updated very frequently. For example, your application is depending on the current weather, which will change every day, right? Every hour. So you cannot, say that, okay, model, you already have the knowledge about San Francisco weather. Like, give me the update. Or look at the stock share price, right? It changes every now and then. So you have to read the current status to go with the questions based on the current event, right? That's where the tools are so helpful. Or in an enterprise system, you have a Jira ticketing system. So you are asking the question, hey, I would like to diagnose how many tickets are handled within that SLA last 24 hours, right? So the model is not trained to have that last 24 hours of data. So to handle the current events or the data which is so dynamic, and you need to get that data at the time of inference, that is where we need tools. And trust me, for agents, tools are very, very important. Okay, so we talked about like the choice of data sources, the choice of different models, choice of tools, right? And once the model is built, how are you going to evaluate it? What kind of an ecosystem that I have? So AWS, so we are going to talk about all these areas moving forward from a flexibility perspective. And next comes the AI you can trust. This is more of a security side. So what are the guardrails that you can apply as part of your system, which helps you to avoid prompt injection, jailbreaks, content filtering, etc. Whether is it compliant as per your own needs. And at last, maximizing value. This is more of scale, right? So once this is implemented, how the monitoring is going to work. How can I optimize the model's performance further? Right? What are the different metrics that I'm going to use? So metrics are very important to measure the model's performance. Either it could be toxicity, or it could be robustness, or accuracy, blue. There are multiple types of metrics are there to measure the model's performance. So the evaluation framework is very, very important. And moving further, like how do I scale the model performance for hundreds and thousands of users? What is the latency that I need? What kind of a throughput that is needed? And how do I balance the performance and cost together? Because as your usage goes up, your cost is also going up. So it's very necessary to balance between the performance and cost. So let's look at the further slides on how AWS is helping to achieve all of these. Right, so I'm going to start with AWS AI stack. Let's spend some time here, okay? This slide looks a bit complex. So to make it very simple, there are 3 different layers of the AI stack. We'll go bottom up, starting from the infrastructure perspective. Infrastructure is very easy. Let's say you just simply need a GPU instance, right? Let's say you need a H100 based GPU instance. Or let's say you need a kind of the L10 or L40S kind of a GPU instance. Simply you need that hardware, get that instance spin up using EC2, and then you start doing the fine tuning or inference, whatever you want to do. You are on your own completely, right? That's very simple. But at the same time, let's say instead of GPU, as you feel that GPUs are expensive for me, and in terms of the availability, also it's a challenge. I would like to explore an alternative accelerator similar to a GPU. That is where AWS own Trainium and Inferentia, which are alternative to GPUs. But the thing is, you need some level of a skill to recompile the model and host it with Trainium or Inferentia. So Trainium is meant for training and fine tuning, while Inferentia is focused on inference only, right? So that's just a simple infrastructure. We just get access to that infrastructure. But let's say you as a customer, okay, so my organization is very focused on data science workflows. I have a large team of data scientists and ML engineers who actually work on the data. They do the data preparation, and they train their own models or fine-tune the different foundation models, and they themselves do the ML ops and finally deploy the model, right? So the end-to-end data science life cycle. That is where Amazon SageMaker is so helpful, right? So it's more of a data science friendly service. So that's about the infrastructure. Then going up, the middle layer is Amazon Bedrock. So today's focus is more on Amazon Bedrock. On the middle right, you see the agent core. We will dive deep into agent core capability on how you can scale your agents with using agent core. And on your left, these are the simple capabilities of Bedrock. Amazon Bedrock in a nutshell is a managed service where you don't need to worry about managing your infrastructure. So you don't need to worry about what kind of GPU you need or what kind of different software stack that you need to fine tune or train, host or inference to the inference of your models, right? So there are multiple capabilities and features of Bedrock. We will have a quick look at the Bedrock side, but in a nutshell, it's a managed service. Yeah.
I can ask questions during, right?
Sure.
Say I have my own infrastructure, like I have on-prem GPUs and the model training happens on my own clusters. Is it then easy to integrate with Amazon Bedrock too? Or are they supposed to be used
So
together?
first of all, why do you need, right? I mean, like before getting into the service side, what is your requirement? See, you have done your fine tuning there. So you have the fine-tuned model already available. Do you want to do your inference in the cloud? Is that what you would like to do?
Yeah, I'm just wondering if you have like the infrastructure parts already on-prem, then can you integrate with Bedrock, or are SageMaker and Bedrock supposed to be used together?
You can do that. My question is, what you want to do? Okay, so to help you, so there is a feature called custom model import within Bedrock. You can train your model elsewhere. Either it could be on-prem or your own laptop or anywhere. And there are few supported architecture within custom model import. So you host the model within Bedrock, your own model within Bedrock using custom model import, if the architecture is supported. Or there is another option called the Bedrock Marketplace, where a lot of new model providers, they would like to sell the model through Bedrock Marketplace, and anybody could use that Bedrock ecosystem along with the new model. Within SageMaker also the same. So once you have that model trained elsewhere, you can actually keep that in an S3 bucket, and you can use SageMaker to host it in an endpoint. Does that answer your question? So this is about fine tuning and inference, right? But it could be the other way around also. You could use SageMaker or a Bedrock to fine tune your model, download them, and do the inference elsewhere. Because the model is a model, right? Great. So again, the next one is the SDK for agents. So we will cover it today, the Strands side of it. So there are two different type of agents. Strands is an open source agent from AWS. All right. So we'll have a look at it, and then I will go through a few scenarios about Strands agents. Then Noah Act is a kind of an SDK which could be useful for for performing any actions within the browsers. And the last layer, the topmost layer, is the agentic application. These are out-of-box agentic applications from AWS. For example, Amazon Q. So Amazon Q got Amazon Q Business and Developer. So Developer is so useful for SPLC life cycles, right? So I'll go through that separately. And Transform also we'll look at it later. But in a nutshell, the top layer is all about out-of-box agentic applications. So you may have a question. Okay, there are too many things. There are too many choices for anybody to choose, right? So which one to start with? Let me give you some kind of an example. Say a customer A or organization A, which is a startup. They are building models on their own. They have their own set of models, right? So in the sense, all they need is an infrastructure with a bunch of GPUs or a bunch of training and inference. So, but they want to integrate it more in a data science environment. So in that case, they prefer to go with a SageMaker. SageMaker has another product called as Hyperpod. So with a hyperpod, you can do the training at scale with hundreds and thousands of instances. Example 2, right? Organization B, they already have a kind of a model trained as she told, but they would like to host it in an environment where they don't need to manage the infrastructure at all, right? So that is where they use Amazon Bedrock to use their own model. Or even another organization who does not want to manage the infrastructure at all. All they need is access to a model, a base model, where it can be accessible easily via SDK, right? Because they don't have skills in terms of building or fine-tuning or deploying the own model. They want to access these model capabilities quickly because they have application builders. So they want a SDK level access to the model. Again, Bedrock is the right choice. So there are multiple such examples. So end of the day, what I wanted to convey here is, it all depending on the personas, right? So different services for different personas and requirements. Okay. So let's go through some of them. So let's go through some of the services in here. As I said, Amazon Bedrock is a managed service from AWS, where you don't need to worry about managing the underlying infrastructure. So where there are a bunch of models available out of box. I'm going to show you what are the models available as of today. So choose the best model available. You may ask the question, how to choose the best model? How do I know which model is better, right? One, of course, you may want to look at like what kind of a use case or a business problem that it can solve. Either it's just a text generation, or it's a video generation, or it's a video summarization, or it's multi-model with both image as well as text capability. This is one thing that you may want to do. So let's say you decide, okay, I want to go into a text generation model. Okay, within text generation there are multiple models in place. Which one to choose? That is where Bedrock comes with something called as Bedrock model evaluation. So if you have a ground truth data with model evaluation, you can evaluate which model is better for your own data set. All you need is a ground truth data set. So you can compare between, let's say, Claude, Llama, and any other model of your choice, and publish metrics around that, compare it, which works for you, and go ahead with it. Right? So that's one of the best practices that I suggest always. Next comes this optimize for cost, latency, and accuracy. So within Bedrock, there are multiple options available. The default one is the multi-user on demand. So you are in a shared pool of resources where we have a backend infrastructure. Like it's like the ChatGPT, for example, right? So you come in and you use it on your own via SDK. But there are a few customers saying that okay, on demand has its own limitation. At one point of time, you will end up a throttling, right? But let's say enterprise customers, they wanted to have their the specific set of latency or a throughput being achieved all the time, right? So that is where Bedrock has got latency optimized as an option, where you define what is the latency requirement, and then you work backwards from there, and that will be a separate kind of a feature available to you for your own. And similarly, for throughput optimization, there is something called as provisioned throughput within Bedrock. So next comes this, the securely customized your own data. There's something called as guardrails. I'm going to talk about it next. And then apply safety and responsible AI checks like content filtering and all, as I told you before. And finally,
could you tell us a bit more about what you were saying about different requirements for applications built on Bedrock versus traditional services like IAM or Cognito? Why would I use Bedrock and not traditional services already offered by, let's say, cloud much for those?
so can you define the traditional services?
IAM, Cognito, EC2.
Those are all part of the parcel, right? So we are going to look at it. When you build an end-to-end application, the model part, the model inference part, that is where the Bedrock comes into the picture. And the rest, everything is going to remain the same. your containerization or the end application what you're trying to build, those building blocks like IAM, Cognito and all that remain the same. And we are going to look at it as part of the agent core as well. Be with me. Yeah, so like, I'm really bad at this clicker, okay, sorry about that. So these are the different models available as of today, starting from Anthropic to Amazon. Yes, we have our own set of models in Nova, starting from text generation to video generation to image generation, and models like Cohere, DeepSeek. So all of these models, whenever they get released, immediately be available in Bedrock also. So the last one, what we worked on is the OpenAI models. When OpenAI open source models got released, the same day it was available in Bedrock, right? So similarly, for example, I work with Meta a lot. I handle most of the time the Llama models and the OpenAI models, not only in Bedrock, but across all of these services. So same happened with Llama as well. When Llama 4 was launched, same day it was available in Amazon Bedrock. Right. Let's look at the guardrails. So first, how do you protect the jailbreaks, prompt attacks and all? So guardrails and Bedrock guardrails comes with few set of configuration where you can actually apply for prompt attacks, jailbreaks, automatic reasoning checks. Through that you can avoid the hallucinations and the content filtering. Let's say you want to filter few content generated by the model automatically. You can put those words and then make sure that it gets redacted or removed as part of the interface. Similarly with the PII. PII is very, very important. For example, somebody's application depending on our own IDs, like let's say a license or SSNs, etc. Right? So it's too dangerous to share those information with the model, right? So that is where you have few guardrail configurations to identify them and redact them. More than PII, PHI is another one, personal health information. In life sciences, nobody is ready to, or even we ourselves won't be sharing our any health information, right? So redacting the PII and PHI is very, very important as part of protecting your sensitive data. SageMaker AI. SageMaker is a very, very a big topic, right? It takes at least 2 to 3 hours to talk about different features of SageMaker AI. But I'm going to keep it at a very high level within one slide. So in a nutshell, as I said, SageMaker is the service meant for data science workflows. You can start from the data preparation to MLOps, to fine-tuning, retraining, model deployment, etc. And you can also customize foundation models. When I say customize foundation model, let's say like you have a Llama or an OpenAI model, which are open source. You want to fine-tune it within your own data set. That's possible with SageMaker, right? And the governance part of it, it's so big. The MLOps is a topic itself. It has got a lot of things to cover. But in a nutshell, it supports the ML governance, end-to-end data science lifecycle. And finally, you can also manage and deploy the ML models. Either it could be a real-time endpoint, or it could be a batch workload. So, or you just use SageMaker only for training your model and then move it to Bedrock for inference. So SageMaker has another thing called as Jumpstart. Right? So Jumpstart's focus is basically ease of use. In one click, can you deploy the model? In one click, can you fine-tune the model? So Jumpstart comes with a lot of recipes built in, with everything built in the form of a container image. So you go to Jumpstart console, select the model, and then say deploy. With the instance needed, it will get deployed in one click. Same with the fine-tuning. There are you can do the fine-tuning or the evaluation, etc. So the main focus of Jumpstart is ease of use. Hyperpod. So as I mentioned earlier about the startup example, let's say the customer is doing a model pre-training which needs hundreds and thousands of GPUs. How do you manage such a large training cluster at scale? That is where Hyperpod comes handy. It's a managed service which is highly scalable. Trust me, there are a lot of model providers today, what you have seen before in that slide, right? They are using Hyperpod or training their own models. So it's highly scalable. And it comes with a lot of recipes for fine-tuning and training. And recently we launched the support for EKS, which is Elastic Kubernetes service within Hyperpod, where let's say for example your end application is based on Kubernetes. That is where you leverage EKS as a service within AWS. And you can use a combination of EKS plus Hyperpod. And also, if you are a fan of Ray, R-A-Y, Ray, it also supports Ray. Okay, so that's pretty much from the first part. I think that the model foundation. Let's stop for a moment. Any questions?
You were talking about protecting PI and PHI. I don't know a lot about what you're discussing today, but I was surprised to hear that you would deal with that in the training or rules implementation for AI. I would have thought that it would be handled at the ingestion phase of the raw data. And so, yeah, I guess.
Yeah, so that's one way to put it, right? So when you say training, it could be a pre-training where you train the model from scratch. There you have a control on the data, and that data it's unlabeled, right? In pre-training, it's more of an unlabeled data. It goes token by token, right? There you have some control. But when it comes to fine-tuning, you are very focused on your own domain-specific data set. So it's very important to filter out those information when it trains. And not only that, at the time of inference, you don't want to give unnecessary information at the time of inference. So that is where you redact the PI and PHI data. Sorry, your question.
Yeah, on the last few slides, we talked about Rock and Savior. Are those like downloadable applications or those websites? You say like you use them.
It's available within AWS as a service. So you need to have an AWS account. Once you have that, then you can either access it through the console or you can access it through the AWS credentials from your account. So it's a service, it's not downloadable. Any other questions? Okay, I hope it's going good so far. How are we doing? Okay. So I welcome feedback, by the way. If you have any, if you feel like I'm going fast or slow, please let me know. Yeah. Okay, here we are. AI agents. So why do we need agents first? You can, okay, let's say if you are a user of a ChatGPT, you just go and ask the question, it is answered. Why do you need an agent?
You can be, the question can be kind of specific, and yeah, I guess you could ask an agent a specific question that maybe Google wouldn't have a specific answer to.
Okay, that could be applied with a kind of a business logic with the if else, right? And then what is the part of agents there? So why do we need agents? Yeah.
If you want to automate a complex task where there isn't necessarily a straightforward way of doing it, like an API, you can. That's my impression, is that an agent would be able to navigate and figure out that task without a direct function capability.
Yeah. I mean, you're good. Let's listen from it. Yeah.
To automate complex tasks.
Automate complex tasks. Yes. Okay.
I think that there's value in that it helps kind of remove the human as being an interface between outputs from the model and subsequent prompts that come through. Like you can give an agent a high-level task.
Yeah, exactly. So for a simple task, whatever he said, you go with the business rule with the if-else logic, it works. That's good for the normal generative AI assistants, right? So you have a simple chatbot which is purpose-built to solve a business problem. Then you go with the business logic with a simple, if-else, etc. kind of a loop. It works. Next, the generative AI agents, where you want to achieve a goal, but you want to achieve broader set of tasks, right? Depending on the answer by the model, you further do the reasoning, and if it is failing, take further action. If it is failing again, then go to another tool, find the answer, check whether it is right or not. Likewise, you keep on going until you get the answer, right? That's more of an automation with the reasoning, right? So the last one is even further complex. Agentic AI systems, where you got hundreds of agents. How do you manage them? And one talking to other. So how can you manage that kind of an automation of these agents at such a scale? That's where the agentic AI system comes to the picture. Okay, so these are the different agentic use cases across different industries. I'm not going through each of them. If you have any questions around the use cases, let me know. Right. So what are the different frameworks for building the agents? I think some of our friends here are already building the agents. Which framework are you using? Not here? Okay. So these are the common frameworks what we hear. There are multiple available, but these are the common frameworks what we hear from our customers who are using, like because most of them are open source. Be it LangGraph, Llama Index, or our own brands, which is also an open source, SDK based. So let's say you build a prototype for the agent to solve a specific business problem or set of business problems with one or multiple agents together. The prototype is successful. Okay, so how you take that agent to the production? When you take that agent to a production, there are multiple challenges. What kind of an underlying infrastructure that you need? How are you going to package it and then serve that as an application, right? How one agent is going to talk to the other agent? What kind of a security system that I need to apply? So finally, your end goal is to meet the business value. We are going to slide number 1, what we have seen about the GenAI journey. Our end objective is to bring the business value. So these are the different challenges. Performance at scale, security is another challenge. Then the governance, end-to-end governance is a challenge. So here you see different set of agents, right? Let's go to the department's agent, which works within a specific team or a department. You take, let's say, HR department in an organization. So which is responsible for answering any questions related to HR policies, leave policies, let's say your pay, blah, 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 right? So that works only for that department. And there are multiple tools. Again, going back to tools, right? Why do we need tools here? Can anyone give me an example? HR department, please. Okay, so let's say it has to pull, sorry, you were saying something? So let's say it has to pull the employee information, right? What is his or her joining date, name, some kind of a record, etc. Then the model will not have a knowledge about those, right? The employee information has to come from the internal database. That's where your tool is going to pull in those information, right? So let's say you're asking about the policy. The model may not be able to give you that policy right, immediately. Instead, it's going to pull it from the system, which is outside the model. That's why you need a tool to pull in the external information. And then at the organization level, at the company level, right, there are multiple such departments. HR, then you have different sales team, marketing teams. Everyone has their own set of agents, and that works for their own set of operations. But when you apply the same across the organization, let's say an employee who has question about marketing, who has question about the HR as well, right? That is where you need these two agents. It has to interact between both of these agents, right? So that's at the scale what we are talking about. This is still within the organization. But outside the organization, let's say you are interacting with the bank chatbot, and bank chatbot, try to understand about your current account statistics. So where that information comes from, it has to have an internal tool to go and pull in your information, depending on what you provide that information. So that's how it is department-wise, organizational-wise, and external. How do you scale from your single department or a single user to hundreds and thousands of users? That's a challenge. Okay, so these are the different building blocks. Now we are going to go through one by one. How to securely execute and scale agent code. Say our friend, I don't get your name.
Yes.
Can you help me understand which framework have you used as part of your agent? Like LangGraph, which agent have you used?
I've been doing stuff from scratch mostly, but I've dabbled in LangChain.
Okay. So is it like a kind of a Python script, basically?
Yeah, and then there's like.
So basically, your single agent is finally a one Python script or bunch of Python scripts together, to meet that functionality. Like, let's assume that it's your agent. How do you implement that kind of a script or bunch of scripts together to work in any kind of an environment? It could work on your Mac, let's say, on your local system, but the same has to work on a different system as well, or it has to scale from your local system to the cloud. How are you going to implement that? That's called the runtime. How you manage the runtime at scale. Next is remember past interactions. Let's say you are chatting with a chatbot. It remembers the entire history of your chat, because the question what you have asked 5 minutes back, it should remember that. Otherwise, you'll be frustrated. Okay, I just answered your question. Why are you repeating? Why are you asking the same question? Right. So that's called the short-term memory. It has to remember the current session. And let's say if you're coming back again, then it has to retrieve your previous interaction as well. That is the long-term memory, where your chat session is being stored somewhere and being retrieved so that it can give you better support experience. And next comes the identity. There are multiple levels of authentication and authorization across the agents. Okay, to answer your question, right? So while let's say you have a cognito-based authentication. Cognito-based authentication is only for the application what you are trying to build. There is an access needed for the model which you are using. Let's say if you are using an OpenAI model, it requires an API key. If you are using a Llama API, that requires an API key. If you are using a Bedrock model, nowadays you need a separate API key for that as well, right? So there is the authentication for your front end. There is an authentication for your model. There is an authentication for your external tool usages. What are the different tools that you are trying to access? So there are multiple levels of authentication. So you need to maintain that identity in a very secure manner. So the controls, the access controls. Agentic tool use, as I said earlier, there are multiple types of tools. Let's say you have hundreds of tools. How the agent will know which tool is correct for the specific use case. Right? And then discover and connect with custom tools and resources. So we'll talk about this. And finally, the observability. How these hundreds of agents working together, and what are the different actions performed by them, where it got failed, what kind of an output it generated, right? And how much of a tokens means how much it costs me, right? So all those information needs to be monitored as part of the observed. So let's look at a simple agent, okay? Look at this example, and we are going to apply different scenarios for this example. This is a very simple task. While you have a support agent, say this is strands. Instead of strands, it could be line graph, it could be AI, or it could be something else. And down below, you have a model which comes from Bedrock. Instead of Bedrock, it could be, let's say, SageMaker. It could be your own, which got deployed in an EC2 instance or an EKS, or it could be an OpenAI model which you are trying to access from AWS to OpenAI, right? It's X, model X. So throughout this example, we are going to take Bedrock as an example, right? And then the user. So you have your local environment on and above. Down below, that is AWS. So your local environment is on-prem, or your own, let's say, Mac. So you built your own chatbot, and that chatbot, it is interacting with the cloud to get your answers through the model, right? And the agent is also deployed locally. And it performs 3 different actions only. One, see, this is a customer service chatbot, so it has to access your return policy. Like, consider that it's kind of an Amazon, right? So while you're trying to return, it has to understand what is the return policy for this product, and then get the product info, and finally a web search, right? So these are the 3 different tools that it uses to answer your question. This is a very simple agent. Okay, this can be easily deployed with a simple script which can run in your own Mac itself. Now we are moving on to Bedrock Agent Core. So keep that architecture in mind. Now we are going to apply more complex tasks into the same. Yeah.
So from the previous example we showed,
Yeah.
Can you give me an example where you can draw a line, on what information to give the agent and what it should find by itself? How do you know that? How do you keep that balance? Does that make sense?
Yeah, I mean more of a reasoning, right?
Yeah, some information, for example, if you're using Kubernetes, you'll give the length of the number of pods or the cluster info to the agent and it'll answer accordingly. So where do you draw that line? Okay, this information the agent has to know, and this information I have to send it to make the agent understand.
So what you need to understand the model's knowledge, right? That's what I said. How much of a breadth of knowledge that this model has, and 2, while you want to draw a line, the line should be drawn where, let's say, the Kubernetes example, what you said. The model may be knowledgeable on Kubernetes in general, but let's say it's your custom built Kubernetes cluster configuration, it will not definitely know about your custom configuration. You have to feed that data into, so that is where you get that data using a tool, write a Python function to do a Qflow or commands to go, the EKSCTL or kubectl command to get the configuration, right? So that is very private to you. The model will not have any idea. So the line is about which is private and what is public, right? And even within public, many models will not have knowledge on every topic. So you need to look at the model card. So what the model card will explain what in which data set this model is trained. What are the different areas of knowledge for this model. So that's where you draw a line. So yeah, so Agent Core is again part of Bedrock as a service to manage your agent orchestration at scale. Right? It brings in time to value. You can build multiple AI agents without worrying about the infrastructure in the back end. It's like the Bedrock service, what I said earlier. That was from a model perspective. This is from an agent perspective. So you build agent, develop your agent, leave that infrastructure management to Agent Core. Okay. And then it's flexible. You can create agents with any framework or any model. So we have seen different frameworks like LangGraph, 2AI, etc. Likewise, it is flexible on the models as well. You It could be from Bedrock, it could be from SageMaker, it could be from EC2, it could be outside AWS as well. It could be from OpenAI, for example. It could be a Gemini model with Google. So it's completely flexible. It could be any model, any agent, any framework. Then trusted. End of the day, while you have access to a lot of different sources, you need to have, you need to protect the agent very clearly, right? Otherwise, it will be exposed to different threats. So how do you deploy them securely? So the previous example, what we seen, right? That's very simple, from local to cloud. How do we enhance it with the memory? So as I said earlier, so memory is all about how do you retain the short-term and the long-term memory. You should have options within the agent itself. So let's say your short-term memory could be maintained within the same compute infrastructure what you have. The long-term memory should be kept outside so that it can be retrieved on whenever it is needed. When I say outside, it's not outside AWS, it is outside your agent's infrastructure, agent's instance memory. So in a nutshell, it abstracts the memory infrastructure, scales automatically with the serverless architecture. So you don't need, serverless means you don't need to maintain the server or the infrastructure in the back. And the complete data privacy, because it will be maintained for each customers or each users separately. Otherwise, I'll be able to retrieve your chat history or the other way around. It is not secure, right? So there is a clear boundary maintained between different interactions and sessions there. Encryption is also available if you want to encrypt it further. That's still possible. So zooming in, agent core memory. So you have an agent, and there is an agent implementation. There are multiple events happening in terms of messages as well as the agent state. How the short-term memory, as I said, your chat messages and the session state, that's all maintained there. And there's a long-term memory which is maintained outside that infrastructure separately, which is semantic, and you can do a summary of that specific session, what happened throughout this session, etc. And finally, there is an automatic memory extraction model through which you can actually retrieve the short-term or the long-term memory, and then convert them as a schema for your later usage. So that's just a model. Sorry.
What does semantic mean in the long-term memory?
So that's kind of a semantic search capability. A semantic search capability. So, okay, semantic is very basic. So in a nutshell, it's based on, let's say, vectors, for example. If it is vector based, then you can do a semantic search across many of the sessions and then find the right one. So let's check about semantic, what is the semantic, but let's not go through the semantic. But in a nutshell, it's a semantic search. So, for example, it could be a similarity search, right? You are searching for something, you look for a semantic similarity. Enhance it with memory, again, as per the same workflow what we have seen earlier. And additionally, you are seeing the agent core memory to retrieve the sessions and the previous sessions, either it could be a long term or the short term. Still, all of your tools are available in local, but your memory is being maintained within the cloud. Next comes the gateway and identity part of it. So there is something called as agent core gateway. So how many of you know about the model context protocol, MCP? So MCP in a nutshell, while you do the inference with the model, you want to streamline how the context format it looks like. Right? Otherwise, it will be completely unstructured, or it could be anything. So it's like, let's say, our TCP concept, right? So you have a protocol in which the peer-to-peer communication happens in a network. Likewise, MCP is a standard protocol which is being, it's currently being, it's trending, I would say. It's a kind of a protocol for the communication with the model. A standard with the standard, let's say the format of input and output. So you can access thousands of tools through a single secure endpoint. So why do we need to access through gateway? Let's say the tools are within AWS only, you may or may not need gateway. But let's say the tools are outside your your network or a VPC of AWS. That's where you can use gateway for proper authentication. You can use multiple external tools. Then intelligent tool discovery. Let's say you have hundreds of tools. Which tool is more relevant to your use case? You can do the discovery on your own, and you can find the tool automatically. Let's say these are the 4 different tools which are applicable, specific to the prompt or specific to the use case. And integration with the agent core identity. So let's talk about the identity part of it, right? Again, coming back to your part, it streamlines the authentication workflow. As I said earlier, there are multiple types of authentication, access roles, and authorization available throughout this process. One is your application-related authentication, 2, the model-related access, and the data access, tool access. There are different types of access and authorizations roles available. So through IDPP, you can manage all of them seamlessly. And you can also integrate your existing authentication mechanism, either it could be Okta-based or Azure AD or Amazon Cognitive. So the integration is seamless. So in a nutshell, agent core identity for access and authorization, while the gateway is meant for external or the MCP. For example, the MCP. Okay, I'm sorry, I got cut out on MCP. So while for MCP, you need a separate server, right? But through Agent Core Gateway, you can register that MCP server as an API, and you can seamlessly communicate with MCP server through the gateway itself. You don't need to have a separate MCP server communication. Okay, so moving in the Agent Core identity, there are 2-level types of authentication. One is inbound, another one is called outbound. So as you can see on the left side, the inbound authentication, it's all about the authentication for the app. Authentication or the IAM roles, what you use for the different services, how the users actually using the application. And once you are authorized, once you are within that agent or the application, the outbound is about how do you communicate externally, what kind of an access is needed for the outbound communication. Let's say it has to communicate with different set of external tools. It actually does a kind of an OAuth, it also maintains a kind of a secure vault through which, let's say you have an API key for the model. Once it is authenticated, it automatically maintains your API keys within that secure vault itself. Gateway. So you have an MCP client which is accessible through the HTTP streaming. So you can have the MCP server running elsewhere. Either it could be on your laptop or it could be on your a different cloud or at on-prem. The MCP server could be running elsewhere till it can be accessible through the HTTP streaming. So which you can be registered as part of the Agent Core gateway, and you can seamlessly access them. The API endpoint target, let's say you're accessing an external tool. For example, you are accessing the Autumn tickets or OpenTable. Those are the external tools that you are interacting with. So there is an API endpoint usage for those websites, right, or the applications. So that's where you can use the RESTful services, And AWS Lambda is another service from AWS called as, it is basically serverless. Forget about, let's say, GenAI part. Even before the era of GenAI, Lambda was one of the powerful service where you don't need to maintain any infrastructure for running your code. Let's say you have a code, you just simply trigger Lambda, runs, and then gets you the output. You don't even know what kind of an infrastructure that is being used in the backend. It's completely pay-per-use, so you don't need a separate server or anything. So that is AWS Lambda. So let's say if you're using AWS Lambda and accessing your tools outside through Lambda, then also you need to go ahead with the agent code gateway. Any questions so far? Okay, now the same workflow with the gateway and identity. So as you can see, so okay, tell me what is the difference? Other than the addition of the gateway and identity, there are few changes to the workflow.
There's no more web search? Oh no, it's still there.
Sorry?
Sorry, I thought web search wasn't up there anymore, but
This one?
Yeah, I see it down there now.
Okay, sure. What else?
The agent can access tools that are no longer just in the local environment. It can go into the cloud and do more like decentralized data.
Yeah, I think even previously also we had the same, right?
Oh.
Any other pointers? Okay. So previously we had the web search running there locally. Now it got moved to the cloud. And we got additional 2 tools to check the warranty and the customer profile, which are running within the cloud. So in a nutshell, out of 5 tools, 2 tools are running locally and 3 of them which are running through the cloud. So how do we manage both of them? That is through the Agent Core gateway. And Agent Core identity, again, it got integrated with the Cognito. So these are the additions in the workflow. Make sense? Next comes the Agent Core runtime. So Agent Core runtime is the core part of the Agent Core, right? So at the time of running your agent, how do you manage that runtime? That is, Agent Core runtime. In a nutshell, let's say you have a script or a bunch of scripts, which is nothing but your agent. So how you make it operationalized with the container image. So all you need is just give a couple of lines of code. It automatically package your code into a container, right? And then easily that can be scaled across many different agents, or it can easily talk to multiple agents, interact with different agents, etc. So basically, how you scale the agent, what you have developed into the production stack. That is runtime. Agent for observability comes with the monitoring part of it. As I said earlier, whatever happening within the agent or from agent to agent, you are monitoring the traces of what's going on so that you can further optimize it for better performance. Okay. So this is how the runtime works. As you can see that there are different types of models. The logos you see, OpenAI, Gemini, and our own Bedrock. So it is model agnostic. It can be any models, and the frameworks can be anything. And at the time of running it, you just use some of the runtime decorators. It packages into a container image, and it writes a Docker file also in the backend while it does the Dockerization. So it does not mean that you don't have the flexibility. You can still access to that Docker file if you wanted to change anything, the way that it gets packaged as a container. So play around the Docker file, and it gets pushed into Amazon ECR repository. So ECR repository is Elastic Container Registry, where all of your container images are being maintained. Basically, it's a placeholder for your container images. So the agents packaged as a container and pushed into the container repository. and it can be accessible as a endpoint. All you need is a URL with a code to access your agent. So observability, as I said, once the agent gets deployed into runtime, and once it starts using the memory, the agent core memory, and all the tools, for every action is being monitored and then logged as part of the CloudWatch. So these are the different dashboards available for complete monitoring. Same workflow added with the observability. And finally, you add a front-end application. A simple Streamlit app, or it could be your own web app, a React-based web app. It could be anything. So putting them all together, you have the models, there is a client, and the center of attraction here is the agent core. But before that, you have a framework with the agent instruction. Agent instruction is nothing but the prompt which you are sending, right? So what kind of a question that you are asking. And then it got access to the local tools and the context for that agent. Context is nothing but the MCP side of things. So then through MCP, there is an interaction with the agent core gateway, because all these tools and everything are outside, including MCP. So it gets accessible through the gateway. And there is a component called as agent core browser. We didn't talk about that. But in a nutshell, let's say if you want to perform any actions at the browser, let's say you create an agent, look for your own list of preference of restaurants in OpenTable, and book a table for the dinner using OpenTable as an app. Like, consider that's a scenario. So you have an agent. So what using agent core browser or even Nova SDK, it can automatically open your browser, go to OpenTable, and it can look for the availability of the restaurants of your preference and book a table. Or the same can be done for booking the tickets for any movies or any shows. Right? So basically, perform any actions using the browser. Agent core code interpreter. Let's say if your agent wants to generate some code and you want to try that code in a sandbox environment, that is where the code interpreter is more helpful. And down the line, you can see the core identity, observability, and the agent core memory as we have seen earlier. So this is the complete picture of agent core and the different components, how it plays between each other.
Regarding the previous slides for
Yeah. I'm still back with that. Okay.
So, in the traditional application, there is a controller or connector between the front end and back end. In this specific, the AI applications, how this data retrieval or delivery will happen?
It is still the same front end and back end. There is no difference at all. This is just a representation at a high level. So it's still the Streamlit app is your front end, and in between there may be a kind of an API gateway where it gets communicate with the back end, the complete agent side of things with the back end through an API. But that's not the end-to-end architecture. This is just a workflow representation. Okay. So let's look at some of the agentic applications. One is Amazon Q Developer to automate tasks across the software development lifecycle. Say, for example, it has got a software development agent which can generate codes and depending on the prompt what you type, or it can do the code review. It can generate the documentation. There are transformation agents which can actually transform your code from the older generation to new generation. So this is interesting, and there is a case study of NAMU, which is available, published, where they have used the Q Developer specialized agent, and then they have done some kind AWS Transform is another agentic application. This, where, let's say, if you want to do some kind of a modernization or the migrations, so it helps you out of the box, right? Again, there is a case study from Thomson Reuters where they were able to save 30% cost by using AWS Transform, and they're able to transform from the previous generation of .NET to the latest one, right? Hero is a very purpose-built IDE, like your VS Code, for example. Or if you have any choice of the IDE, different IDE tools that you are using. Similar to that, Hero is a very purpose-built IDE for agents, for developing agent and then moving them to production. This is again open source downloadable. Okay, so let's go with the customer stories. So there are hundreds of customer stories available, but I just picked 3 of them. One is Epsilon. Epsilon was able to, reduce their campaign build time by up to 30%, right, by using the agent core. At Innovation, they were using only the agent core gateway for their own MCP server, and there is this is the statement from their CEO and co-founder. Box is another use case where they were using the agent core runtime alone, not all the components. So whichever the components that we have seen as part of agent core, they can operate in silos. You don't, let's say for example, you can go with agent core runtime alone. You can go with only the gateway alone, right? So either you can go with a mix of all the components together or standalone. Some QR codes for you to try it out. For example, the first one is about the strands agents. The second one is about the agent core documentation, whatever that we discussed so far, it's available there. Third one is about the GitHub examples of agent core. There are a lot of use case specific examples available there. And then Meta Llama on AWS, whatever the resources specific to Llama models on AWS across Bedrock, SageMaker, and self-managed. Anthropic on AWS with Bedrock. OpenAI, open source models on AWS. So these are only some of the QR codes. I can come with hundreds of QR codes, right? But this is more relevant. So that's what I had today. I'm open for any questions now. Really, thank you.
There was a part about memory.
Yeah.
Long-term and short-term. How does it determine what stuff is long-term memory?
So there is a session ID timing which is configurable, the time to live. So you can configure the timing. Until then, like we can actually maintain that at a short term. And after that, it can be moved to long term, right? And it's still configurable.
Okay. So it's just like time-based. There's no
Time. Any other questions?
Have you seen a trend in requirements for companies that want to deploy agents?
Oh yeah. We are already working with many customers.
Is there a difference between deploying traditional web servers and deploying an agent? From the latency.
So the traditional web application development is being updated now. So I think there are a lot of discussion around this from Microsoft, right? Online clouds available. So traditional development is being changed to agentic.
Right, but in terms of, let's say the application is running, if you think in terms of latency, CPU, memory, you mentioned latency should be lower, but something else or?
Not necessarily, right? I mean, so latency still you need to evaluate. That's a iterative approach. So you try with different approaches, different models. So you need to work backwards from what is your latency requirement, whether this can meet the requirement or not, and how you optimize your entire solution for the latency. That's a completely iterative approach.
So it's from the, let's say you do the SRE at AWS, and you see all of these agents in the code. You can just treat them as web servers.
Web servers could be one of the application. There are like multiple use cases, right? So there are multiple use cases that I have shown at this. Use case specific. Right. So basically it's a kind of a server, which can be on your laptop as well. You need a computer to deploy that to and it's configurable, where you're saying that, okay, all of my communication to this model has to be in this format, let's say JSON, with parameter 1, 2, 3, 4, and some of them are optional, some of them are manual. Similarly, the output, it has to be 1, 2, 3, 4 in a CSV format. So you define which model has to be communicated on what kind of a format. So in a nutshell, that's what MCP is all about, but that topic is very, very busy. Yeah. So think like a TCP. It's a standard how it communicates, right? Similarly, it's a standard for the model to communicate the context. Yeah, of course. Of course you can use it, right? So first of all, you need to define your use case. What you want to do. When you say you want for the studies purpose, what you want to do. Like so you ask a question, what are the different sources it has to go and look for. And let's say if you want to summarize a specific topic or specific lesson that you have questions. Specific questions like let's say you want to generate questions out of that lesson. So you need to define what is your use case and develop an agent which uses that model in the back. Yeah, so that is just one time, and there is no business logic to it. But in agent, let's say for example, you are looking for a specific topic in a book. You are asking a question. Hey, I'm looking for so who I find out in this book. Let's say the answer is not available in that book. It uses multiple tools to search and find your answer until it gets the answer. It does, kind of a reasoning checks in between and then get the answer. So for one-time use case, your ChatGPT or interacting with any model is good. But while you want to scale, while you want to apply the automated reasoning, that is where agents. A knowledge base is a separate topic. Knowledge base, let's say you have hundreds of books which are available through knowledge base. So that's the RAG-based approach what we call it as. Depending on the question, it goes checks your source, get the right book, and then that book passed as a context to the model, and your answer is done. That is one time, but you are still limited by those 100 books which are available within the RAG. What if that question is not being answered within those 100 books? It has to go and find out like in many places and then get you the answer. That is where agents should be.
Hi, thank you for the talk, it was really interesting. I was wondering if you think the agents were designed, say I have a use case that I made an agentic workflow for the HR use case, and I think this could be useful for other companies, for different companies. How easy would it be to deploy that for other people, or is the design kind of, you have an agent core instance running in like one AWS account, and that is for my business?
No. See, if you have access to AWS, Agent Core is currently available on 3 or 4 regions currently. So approach. First, you need to be clear on your foundation. Adoption will be what I said earlier. Clear on your use case. Select your foundation, data, and model. And do some prototype. Develop an agent. Test it out. Then scale using it. So that answer your question.
Maybe I'm not asking the right question. I'm on like, so if I have done this and I have an agent that I think is useful, how easy is it to reproduce in another business? Or is that not the use case for this?
Another business, okay. Another business, all you need is like how this logic works. Once you know how this logic works, there are a few dependencies. First of all, when you say other business, there's other use case, right? For that specific use case, we need to know what are the data sources, what are the tools, and then what kind of prompts that we need to write, right? So there are a few variables, but in a nutshell, the architecture at a high level is the same. The components are the same. As long as you are able to understand the concept, any business doesn't matter, because I work across different businesses. As long as I know about how to solve that problem using these different components. So ground truth is a kind of a labeled data. So let's say, for example, you have your test going on, right? And that questions for that test is being generated by the model, right? And it also generates the answers for verification. So how do you verify that generated questions and generated answers are correct? Let's say you have your own set of questions and answers written by the humans. So using evaluation, you are saying this is the ground truth data generated by the humans, and that is the data generated by the model. So then it will compare, like for this question, this is human generated, this is model generated. There is a metric for that, accuracy, for example. How accurate is model generated versus human?
And then those are the evaluation
Correct.
criteria.
Using that metrics, you are measuring the model's performance. It is like, let's say, 80% right. And then if it is below your expectation, you generate more human generated data and then fine tune that model. So the ground truth data is nothing but human labeled data.
So criteria are
Changes, sorry. So it depends, right? So there are multiple metrics like accuracy, or there is something called as toxicity, how toxic is that response, or there's something called as a BLEU, B-L-E-U. There is something called as a rouge. So, for example, rouge is good for the summarization kind of use case. So depending on the use case, your metric will.
In the customer cases, you talk about Epsilon, and also reduce their time in the activities they were doing. What kind of activities were done by the agents? Could you describe it more?
Yeah, so I showed you the use cases, right? These are the different use cases. Any other questions? Great.
All right, everybody, let's give our speaker one last round of applause.
Hope you find it useful, and as I said, please try out those code repository.